we'll be doing is we'll be taking a look at solving quadratic equations. Now, the big idea for today is that if we have a basic equation, y equals ax squared plus bx plus c, right? When we're solving for a quadratic equation, we're actually solving this equation, 0 equals ax squared plus bx plus c. So we're using the concept of 0. 0 times anything is 0. So when we factor the ax squared plus bx plus c into its intercept form, we're actually solving for that. That's why we end up with our opposite world statements. Now, it's very similar, as I said, it's very similar to solving for x-intercepts for a quadratic equation, because if you think about it, when we're looking at that equation, we're literally taking it, factoring it, and then using the 0 property to actually find our x values. Now let's move on to our first problem of the day. And now what we're going to do is we're going to do this solving by factoring. And when we factor, we're literally going to set y equals 0, and then we're going to do what we would have normally done, how we got opposite world a long time ago. So if I look at this problem here, a x squared plus 7x plus 10 equals 0, you'll notice that it's a simple trinomial. So let's do that. So we need to find a number that multiplies to 10 and adds to 7. So we need two numbers, and we find out that it's 2 and 5. And when we do the factoring, we get this, x plus 5 plus not 3, but 2 equals 0. So when we do our calculations, we're going to end up with something that looks like, you know what? Plus. And now remember I told you we just corrected that, so we have x plus 2. So what this leads us to having is either the x plus 5 is equal to 0 or the x plus 2 is equal to 0 using the 0 multiplication rule, because anything times 0 is 0, right? So in this case, we're going to have x plus 5 is equal to 0 or x plus 2 is equal to 0. Now, when we get our final answer, we end up with x is equal to -5 or x is equal to -2 when we solve for x for both equations. Now, we're going to do the same for the next equation. Now, the next equation literally is just factoring out the GCD. In this case, the GCD is, or the GCF is, x. And when we pull that out, we're left with 2x minus 7 in our bracket. So either the x equals 0 or the 2x minus 7 is equal to 0. So we have something like this. X is equal to 0 or 2x minus 7 equals 0. And then we have to solve for our x value. And in that case, therefore, x is equal to 0 or x is equal to 7 over 2. And both of those x values, when we plug it into that equation, will create a situation where we have a 0 for that entire equation. So we basically balanced out the equation. Now, as for our next problem, there's not enough space here, so we're going to move our problem down here. So when we do this problem, we're literally just bringing the 15 over to the right side to make our equation equal to 0. In doing so, we're going to get an equation that looks like this. 4x squared minus 4x minus 15 equals 0. Now, in order to handle this problem, we have to take a look at something that multiplies, because we have the 4 and the 15 coming together. the negative 15, multiplying to negative 60, and adding to negative 4, the center part. When you do that, the first time you do it, you always go and do your just positive numbers. Two positive numbers that multiply to 60, so they are 10 and 6. But if we choose, because it's a negative, that means the bigger number of those two is going to be negative. So negative 10. Negative 10 plus 6 gives us negative 4, which is what we're looking for. So let's just go and do our factor by grouping. So we have 4x squared, and then we split our middle term to be plus 6x minus 10x. When we do our substitution, we got two brackets, all equaling 0. And the minus 15 goes in the front, and the other one goes here. Now, when we put our final answers in, we have plus 6x and minus 10x. So we have to bring that minus sign in to the second bracket. So now we find the GCD. So the GCD of the first part is going to be 2x, and then we're left with x plus 3. And the GCD of the second one is negative 5 bracket 2x plus 3 equals 0. And now we're going to factor by grouping. So we're going to actually take our 2x minus 2x plus 3, which is common to both multiplicative complexes, which are here, and pull that out. So we're left with 2x plus 3 is equal to, you guessed it, 2x minus 5 equals 0. Now, as we're doing our math, we have to remember we're using the multiplicative rule, right? Either the 2x plus 3 is equal to the 0 or the 2x minus 5 is equal to 0. So we end up with something like this. We split our problem into two parts. 2x minus 3 equals 0, or 2x minus 5 is equal to 0. So now we solve each individual equation. So we end up with 2x is equal to 3. Solving for x, we end up with x equals 3 over 2, or let's go to the other part. So now we go and solve for 2x. So 2x equals 5, and then we end up with x is equal to 5 halves when we solve for x. Now yesterday we talked about completing the square. If you look at this problem, it says a rock is thrown from a high cliff. The equation is highlighted by this thing, this specific equation. Now, for part B, it says how tall is the cliff. If we take a look at A, it says how tall is the cliff. So that's essentially letting t equals 0, i.e., if I take a look at this equation, if this is my equation, this is my y, my h intercept. This is the starting value for my basic equation. Now, what that means is the cliff is actually 135 meters tall. Since this computation happens, therefore h equals 35 is the height of the cliff. So if you were writing this in full English, you would have said it's 135 meters. Now, for the next part of this problem, we have an issue. Our basic equation is given by the maximum height of the rock. We're asking for the maximum height of the rock. So that deals with, anytime you see something like this and you have a basic equation, like what we have to do is we have to do completing the square. So we put the first t and t squared terms in brackets, and then we add the 35. Next, we're going to factor out negative 5 from that bracket. And that's plus 135 for each of those. Just make sure those equations are set up properly. And now that we've done that, we have to find the thing that we're going to add and subtract. In this case, we're literally going to take negative 6, divide it by 2, and then square it. And you end up with the 9. So we're actually going to be adding 9 and subtracting 9 from our bracket. And we end up with something like, so in essence, we've added plus 9 and minus 9 to our bracket. Now, remember what I told you. I said that the offensive part of our problem is this minus 9, and we're going to have to bring that thing outside and plop it outside our bracket. And so when we do that, we have something that looks like this. And we have our t, our value of t squared minus 60 plus 9 left alone, our perfect square in the bracket, plus 135. And then we have to make sure that we bring our minus 5 into that bracket, into that big blue bracket at the end, our collection, our garbage collector. And we have to put our minus 9 here that we didn't want in our bracket. So now you know that when you do your final calculation for this, you know that negative 5 times negative 9 is equal to positive 45. So our new equation becomes this. So now we know that this whole part here is a perfect square. And this whole part here, all we're going to do is we're going to add it up. So now our final answer is h squared minus 5. And in our bracket, notice the squared, we have t and a 3. The minus sign for this bracket literally comes from the center of our term in our perfect square. And then we have 135 plus 45, which gives us plus 180. And it says, remember what our question said. It said, what is the maximum height of the rock? In this case, the maximum height is max height is 180. And it happens when the time is equal to, and let's put 180 meters, and when the time is equal to 3 seconds. So the last part of the problem asks us, what is the height after 1 second? This is how you get it. Well, h is equal to negative 5 t squared plus 30t minus plus 135. So what you're going to do is you're going to let t equal 1 in our equation. So we get h equals negative 5 times 1 squared plus 30 times 1 plus 135. So we end up with negative 5 plus 30 plus 135, which ends up being approximately 160 meters. Therefore, h equals 160 meters when t is equal to 1 second. Now, for the second part, where we actually say, hey man, go find out what it is after 5 seconds. So you could either substitute directly or you could use geometry for this. Now, I personally like to use geometry for this next part because here's what you know. Your parabola has a vertex at 3, 180. Now, your parabola, you know, based on our a value, is opening down. You know its axis of symmetry is here. You know that one of the points was at 1. So at t is 1, there's our first point. 1 is exactly 2 units from the axis of symmetry. And when we take a look at x is 5, isn't that exactly 2 units from the axis of symmetry? Therefore, the height is 160 meters. And that's due to symmetry. tree with x equals 1. Okay? So, now the last part of our problem is to find out this. How long does it take for the rock to hit the ground? Well, you have to start with your basic equation. Then what we're going to do is we're going to let h equal 0. And we're going to factor out a -5 from everything. So you get t squared minus 6t minus 27. Now, the stuff that's in the brackets here is a simple trinomial. We're looking for a number that multiplies to -27 and adds to -6. And that those two numbers are -9 and 3. So we end up with this. 0 is equal to -5, t minus 9, t plus 3. And that tells us right away that in this case, our answers are x is equal to 9 or x is equal to -3. -3 is erroneous because t is greater than 0. T is always greater than or equal to 0. We cannot go back in time. Therefore, it hits the ground after 9 seconds. Now, your homework is these sets of questions that we're going to be doing later.